All right, gentlemen and ladies, I'm going to try to unteach what you know about soil and give you a different perspective. I kind of like to take you out of your comfort zone, take you out of your body and mind for a minute here, and try to get you to look at things a little differently. What is psychical soil? All right. Yes, there actually is a word psychical, and it's psychic and physical. And in many ways, I truly believe that soil is something that's beyond our comprehension, supernatural, paranormal, paramagnetic, spiritual, extrasensory, subliminal, subconscious, clairvoyant. And in order to take this to another level, I want to talk about the definition of life. I struggle a lot with this because, here we are in the 2020, and we say a sperm is alive and an egg is not. I think that our perspective of life and that definition needs to be revisited. We say viruses are not alive. Well, viruses have been around since the beginning, and they have steered evolution. When something gets out of whack, the virus sets in, culls the herd to some degree, and then allows a rebirth to come out of the chaos. And so, again, I think that in this day and age, we should be looking at things, have a better perspective on what we define as life and what we define as not alive. One of the other pieces of the puzzle that I really want to talk about is the fourth phase of water. For you out there, please just write that down in between sessions, or tonight or tomorrow, whenever. Google it. There are people out there that are trying to debunk this understanding or concept. So I don't want you to focus on that. I want you to focus on what was written and what has been talked about. It's kind of like, when you take your shoes off and you walk in the sand, there's a connection there. The sand just makes you feel good. Same as rolling around in the grass, in the sunshine. There's something going on there. There's a connection to the earth through the moisture, through the water, whether it be a mist or a vapor. There's a connection there. And in the fourth phase of water, they touch on structured water, which I'm not a big fan of that term. I like to think of it more as understanding the water's ability to transfer information, millivolts, EC, electrical conductivity. I'm actually reading a paper right now by a gentleman. His first name slips me, but his last name is Bally, and he's actually taken it to a whole nother level. I'm like, without a way to define it other than it's the fifth level. And so some of his work is kind of showing us that inside a bacteria, which is 1 micron, so you can't see it unless you have a microscope, so it's very small, there are 3.3 billion water molecules in that single cell. And the way those water molecules line up allows for information to be transferred from one part of the cell to the other. And so that's kind of the direction that I want you to start thinking about water as well, and life. I think that these definitions really need to be explored deeper. And hopefully in the next few years, we really start to pay attention to some of this stuff. So moving on, this has always been one of the funnest questions I ask when I'm sitting around with a bunch of nerds or people that are way smarter than me. And that is, where does the soil stop and the plant begin? And again, this is a conversation that's beyond what most people stop to ponder about, but it's an important question. And, yeah, you can grow hydroponically, which is in water, but we just talked about water and its properties. So I don't think you can sit there and say that just because you're growing in water, you're not connected to the soil or the what I want to call the aquatic food web, which is very similar to the soil food web. And we'll get into that in more detail as we go forward. But just stop for a second and ponder that question. Where does one stop and the other begin? And it's a deep question, and I've stumped a lot of really brilliant minds with that question, and made them just sit back and go, well, wait a minute, I never thought of that. And so I think it's an important question to ask yourself, especially today as we move through this. Again, I'm trying to get you to think outside the box of what you know, and in hopes that I open your mind to some things that perhaps you hadn't quite thought about yet. So, what are the properties of soil? Soil science says, and this is dogma, that soil is defined by the particulate size and not the properties of the particulate. And to me, that just makes no sense. Sand, silt, and clay all have different properties. If you've ever done a home textural test where you've taken a handful of your soil and you put it in a mason jar, added a little bit of water, and shook it up, you will see it settles out differently. The sand settles first, clay second, or excuse me, the silt second, and the clay last. And then, of course, what's floating is your organic matter. So right away, the specific gravity of sand, silt, and clay and organic matter are all different. And we're going to get into specifics on what the properties of each one of these are. And that will hopefully get you to start to understand that they're critical components in growing plants of any kind. So another piece of the puzzle that is not discussed or talked about often is soil is only 50% physical matter. The other 50% is air and water. And that's where you get anaerobic and aerobic conditions. So in the silt on the bottom of a creek or a riverbed is anaerobic. You step in it and you pull your foot out and you're covered with mud that smells pretty nasty. So that's anaerobic. And on the other end of the chart, you have a desert where you have very little moisture. Now, there is vapor trapped down lower into the sand, but it's very aerobic. So it's almost oxidative. It's almost like very difficult for that moisture to hang around and be supportive of plants. Now, there are some plants that live in deserts, but they're pretty scattered and not a lot of diversity. So remember, soil is only 50% the physical matter, and the other 50%, the water and the air or gas exchange, are very, very important to support healthy plant life. All right, so what is sand? There's really kind of three components to sand. It could either be silica or quartz, and I want you to think about that and look at that molecule. 1 part silica, 2 parts oxygen. So if you have a bacteria in a soil system that is mining silica for the plant, remember the plant sends down exudates to target specific bacteria to mine specific things to then make it available for the plant. So as that bacterium pulls up the silica to make it available for the plant, it's releasing oxygen. And so this is, another key piece to understanding how these components of soil are so important in providing the diversity that you want in your soil system. I've had people say, oh, we only need NPK. Well, we've learned that lesson. There's way more nutrients than you need just NPK. And then I've heard people say, oh, well, there's 17 nutrients. Yeah, I think that's narrow-minded. I think that when you start to think about the biological constituent that goes on, in many ways, a specific bacteria's main purpose could be just to grow and die off and provide a substrate or a food source for another bacteria. So I believe every part of the periodic table is important for advanced life to happen. And at some point in some time, all of these minerals were being consumed or are continually being consumed just to support the next level of advanced life or evolution. Another part of sand can be calcium carbonate. And we all know how valuable calcium is in our soil system for our plant health. Yes, it's basically fossilized corals and shells. Now, I've got people saying, oh, well, we can't get calcium carbonate sand in the Midwest. Well, that's not true. At some point in time, over the last billions of years, everything has been underwater. Everything has had an ocean, a sea, a shallow amount of water over the top of it that allowed some type of crustacean to exist. So all it takes is erosion, and water movement, and in some cases just wind, to expose that kind of material. And I think that another great misnomer is the understanding that the vast majority of soil on this planet, I believe it's about 80%, was moved through transportation or was formed through transportation. So the wind, the water, the sun heating it up, and the water freezing and breaking it apart. So all these things are part of the process of forming soil, and soil often took thousands, if not millions, of years to form in the layers that it did. So keep that in mind as well. The other type is diatomaceous earth, or diatoms. And those of you who have heard me speak in the past, I'm all about diatoms. I think that they are in many ways, the missing link in our healthy soil system at this point in time. Before the great expansion of humanity, all the rivers and creeks and lakes had herds, massive herds of animals running through them, dragging up all of the aquatic food web, including diatoms, up onto the land. Think about migratory birds. I mean, there's stories and pictures of the late 1800s where in the Carolinas, the sky darkened with the migration of these geese and ducks. And those migrated all over the country. So as they took off and landed to eat grass, all of the aquatic soil food web and diatoms were spread across the soil system. And of course, nowadays, we don't have those massive herds or those massive migrations. So in many ways, the diatoms and the other parts of the aquatic food web are not getting up on the soil. Now, a quick little flashback, and NASA did a study in 2011 about the dust storms in the Sahara Desert. And what they determined was that dust went all the way up into the upper atmosphere, floated across the ocean, the Atlantic Ocean, and reformed into particulate that rained down on the Amazon rainforest. And that study indicated that they believed it was providing phosphorus for the Amazon rainforest. Another study that was done, I believe, in 2017, where they took it a little bit further, and they realized that it was really diatom shells as well as some silica sands that were raining down on the Amazon rainforest. And so now the theory is it's more fertilizing the system. So again, these diatoms are very important in the whole ecosystem. And I want to touch on diatomaceous earth for a minute. Now, that is where diatoms have been collected or mined. Specifically, if you look at some of the interesting satellite photography about the glaciers melting, you will see these huge plumes of diatoms happening where that mineral-rich water hits the ocean. And so they plume out, they grow until that minerals are depleted, they die off, and they leave a huge layer of diatomaceous earth on the seafloor. And then as the continents move and drift, of course, billions of years, eventually those pockets of diatoms end up on the surface of the earth instead of underneath deep water. Now, people use diatomaceous earth as a insecticide, and it does have pretty effective properties. Quick story of when I was young, I got to tour a glass manufacturing plant, Foster Forbes Glass, I think it was Hopedale, Massachusetts. And out back, there was this huge pile of glass that had, either screwed up and dumped on the floor, or bottles that weren't quite manufactured correctly. And they would just throw them back out in this giant pile and then pull from that as they needed it to recycle it back into the glass production system. And we laughed about what torture it would be if you were forced to climb up over the top of this mountain and down the other side. What would be left of you? And so that's basically what diatomaceous earth does to micro and macro arthropods. It basically cuts them up and shreds them. And so I've had people in the past say, well, I want to amend my soil with diatomaceous earth. And I'm like, well, I don't think that's a great idea. A little bit is okay, but if you start using a bunch of it, you are going to restrict the ability for that soil system, the soil food web, to function at its full capacity. In other words, if a nematode brushes up against one of those, it's gonna get cut open. And same with some of these microorthopods that are beneficial. You're going to lose them. So again, everything in moderation. A little bit is okay. Preferably get live diatoms, and we will be talking about those at length in the January session and how to wildcraft them or grow them out. And so in that case, you're providing a living animal into your soil system. And again, the interesting thing about diatoms is they actually produce oxygen. That is their off gas. So if you put them down in your soil system, you're feeding oxygen directly to the soil food web that's underground and will consume that oxygen and release CO2 for the plant. So again, you're assisting in the gaseous exchange or gas exchange system that functions perfectly with plants. Another interesting thing about diatoms is they have a biogenetic bond, not a covalent, not an ionic. So a biogenetic bond is easier to be broken apart. And therefore, again, now you're mining silica and other minerals and nutrients a lot easier than perhaps trying to digest a grain of sand. Silt, all right. Silt holds a negative charge. And here again, here's the dogma of soil science. Sand does not hold a charge, but silt does. So why are they defined by particulate size? Another interesting piece of understanding why it's valuable to have a paramagnetic charge in the soil. Think about how you can attract nutrients and store nutrients so that they're not mobile in the soil profile. Well, a negative charge will help tremendously in holding a anion, or excuse me, a cation. So positives and negatives attract, the same positive and positives repel. So if it's holding a negative charge, then it's going to be attracting a cation. And we'll get into the specifics of that in another slide or two. But also another piece of this to think about is that how do you form aggregates? And aggregates are the key piece to a healthy soil system. Aggregates are formed generally through either a positive and negative charge, helping to start attracting particulate together. And then the next level is what happens with bacteria. They create a biofilm, which helps to bond these particulates together. And on the fungi kingdom, it's glomalin. It's another form of natural glue that will help bond things together. And in understanding the physical properties of soil and remembering that only 50% of that is physical and the other 50% is water and air, it's really important to have that aggregation so that water can infiltrate and gas can exchange. So aggregation is critical, and silt is a big piece of helping to form aggregates, micro and macro, in your soil system. Another thing that can take into consideration is silt is an organic matter. It just happens to be very fine. So what comes after silt would be humus, and then humates, and then humic acids, which are a part of humate process. And so you're again providing a very valuable nutrient in your soil system when you do include silt as part of your soil recipe. Clay is one of my favorite. I will bounce back to when I was a kid. We used to mine clay on the side of a hill on a road, and we'd get this really white, almost like anyone out there who's painted and used white paint, if you put just a tiny drop of purple in there, you get like a three-dimensional white color. And so primary clay is white, or this kind of like interesting color of white, not just flat white, has some depth to it. And primary clay has very little minerals or nutrients. It does have a charge, but again, it's not as valuable as some of these colored clays. I've seen blue clay, I've seen green clay, I've seen red clay, I've seen brown clay, and I'm sure you all have too. And the beauty of clay is that it's both negatively and positively charged, which I will get into in a minute. But more importantly, backing up, clay expands when it gets wet. So it has a water holding capacity, and it also contracts when it dries out. And that contraction can cause problems and compaction. So if you look at the center of the slide, you'll see how the clay platelets stand up on top of each other. The outside edge is positively charged, and the flat surface is negatively charged. So imagine if you took the piece to your left and stacked it up on top of that other clay platelet that's upright. Now you would form what I would call an I shape. And some of the interesting studies I've been reading on is that that little C-shaped, negatively charged or paramagnetically charged area is attracting, guess what? Cations. So those are nutrients. So if you stack these up on top of on themselves indefinitely, which is what you will have in a healthy soil system, think of all of the potential nutrient holding capacity clay provides. Again, it's not mobile, it's not going to wash away. And as those root tips and root hairs hit those areas, they can actually pull those nutrients out. And they're essentially plant available. They have been processed at that point.